ring light is on. We're influencing now. We're influencers. We have a very water-damaged MacBook, as it turns out. This repair is not going to be too thinky, because I think I have a good idea of where our problem is already. It's this big mess right here. We got a little bit of schmutz on the back. This is a really good example of what happens if you water damage a MacBook and you keep using it and running power through it. Electrosis, a chemical process. You have a conductive material, you run power through it with water on it, or whatever fluids, hopefully water. The corrosion will happen in real time. If we went in the bottom of the ocean with this thing, we went scuba diving, got some buried treasure, at the bottom, came up, opened our pirate's booty, whatever, days go by, and we clean this thing off with some alcohol, it'd be fine. Plus we didn't run power through it. The corrosion would take quite long to set in. But if you run power through it, it happens, immediately. And then you also just have, the problem of, electricity, potentially causing arcs on some of these components that are in closer proximity where you send, higher voltage, lower voltage, blah, blah, blah. Fire hose goes into bendy straw, causes, the MacBook to be sad. We're going to basically desolder a bunch of stuff that looks like shit on the board and replace it and see what happens. I'm not going to really bother running power through this now. There's some fairly obvious problems that we can resolve before we do that. And the very obvious problems aren't around, like, just for example, if I had a big mess around the CPU MOSFETs here, then I would, not work on the thing because it's fucked. This should be okay. It's around some stuff for audio, probably USB-C. Nothing too crazy. And by a lucky day, it's a rare 16-inch MacBook Pro that doesn't come in where the buck regulator for the SST isn't blown up. Maybe that's bad too. We'll see. It is pretty dusty. First thing we'll do is just kind of clean this thing off. What we do want to do, I want to go on the microscope camera, and I'm going to take screenshots now of all the corrosion before I clean it. This really does not look happy at all, not one bit. I think we'll probably replace that connector. Really this plastic connector though. Probably those pins are going to be burnt, I would wager. I'm basically going to remove all this stuff. Not all of it. Like these, probably okay. Probably a few little parts here. We'll clean it off and see how it looks, but probably all these guys, probably these guys. We'll clean up all the pins on this. I'm going to clean this off and see how it looks. I might want to replace the USB-C connector. It kind of looks like there's going to be a hole burnt under it or something like that. Probably most of this stuff right here looks quite bad. And then we also have a bit of a mess on the back side of the board. Nothing really, even that, it's just on some test points. We can really just clean this off. And then the whole board itself, we are going to ultrasonically clean just because it's very, it doesn't show up as much on the camera, I reckon. Or no, yeah, I mean, it's pretty dusty. We want to clean this thing off. And we will also, we'll check and see what's going on here, but we want to cover this SSD controller with some glue so this guy doesn't have his storage dying in a year because his machine's kind of dusty. Because these do like to die in that way. It's a very silly design. Should have put this chip not right here, but maybe, over here or something. Somewhere not near the edge of the board where the air intake is right next to it and kills it. Okay, well, let's start removing stuff. I'm going to turn on fume extractor so we don't get the cancer. I guess we can look at what we're removing. It doesn't matter all that much. We're going to replace it from a donor board. This is an A2141. Okay. We're looking at right about here. I think this is like G3 hot. I thought this was like speaker amp stuff. So we just have PP bus, S5, USB-C thing, diode for USB-C. I'm kind of feeling like we maybe have a hole burnt under this connection right here. I'm gonna remove this this connector. Let me just clean this off with some alcohol first. This MacBook needs a drink. Okay. That'd be nice if we could just fix it like this. Oh, what a dream. Wow, just like that, it's fixed. It's better now. You know, I think actually after cleaning this off, I will run power through it and we will see what it's doing. Looks like something here exploded. Is that a melted component or is it no stuff? What am I looking at right here? Should there actually be a resistor right here? No, it's a no stuff thing. So there actually shouldn't be anything here, but it looks like corrosion is basically developed enough. Kind of looks like something was here. There we go, that trace is burned right off. Make a mental note of that. I don't think it's going to matter though, because this line's no stuff, so most likely this trace is still running here. Check back on that later. Just want to get all this crap off of here. Yeah, the pads underneath there look fine. I mean, the connector, like, ground shielding is a little bit charred, but that doesn't matter. I'd say those capacitors probably aren't happy. In fact, this one's just falling right off. Look at that. I'll go ahead and remove that. I would imagine this capacitor was probably short-circuiting. It's also not too happy. I am basically using zero pressure to remove these. They're just kind of falling off the board, which is probably a sign that the capacitor is bad. If it's doing that, it's not supposed to do that. That's also rusted to hell. Run some power through it, perchance. I'm actually going to clean up around the buck regulators too. This purchase is a very sad chip. Dies all the time. Or that single capacitor I just knocked off with my tweezers was the only problem and this will work now. That's also kind of likely, honestly. Didn't really see anything else that looked that crazy. What I did see is the current spiked quite a bit and then dropped down, so I think maybe on that spike we'll be able to actually see something on the thermal camera. Right now we're not going to see anything really. It's only drawing 0.3 watts. I tried to turn on though. Let's see what's happening. I'm measuring the voltage on a BP bus right now. 12.6. We don't really see anything getting warm at all. Oh, get out of here. No more bites. Fine, I know what's safe and what isn't. Okay. Let's plug in power again. And I think we'll keep our camera on the area that was super messed up. So that's probably where our issue is. So T2 is getting kind of warm, and then our PMIC kind of flash there. That's actually a little... Huh. Our PMIC might actually be dead. That corner of that chip was kind of flashing on and on. Unless it's quite rare for that chip to die. Let's look closer. We did have that resistor earlier that maybe is causing an open line, and that might just be causing us to like kind of you know, T2 is trying to turn on and then it fails for some reason, so it turns off all the way. And that's why our PMIC is flashing. If it was getting like really, really hot on that PMIC, I'd maybe more think that the chip's bad, but it's not really getting too warm at all. So it's more like it's just trying to turn on, but maybe something else is kind of causing feedback. We see the corner of the chip's getting hot. That doesn't really mean that much. The chip's going to have a bunch of sort of different layers on it. So just because we see like you know, the chip's getting hot in this corner right here, it doesn't mean that it's this line that's bad or something like that. Because there's definitely, you know, there's multiple layers inside of this chip basically. So we might be seeing something really on the top getting hot here, which could, as far as we know, be this line or who knows. Not really as helpful. Okay. What I want to see maybe is we can take voltage measurement of something around here. I wonder if it actually is just this S5 line is short. Let me see what this does. Plug in power. Get the voltage. Switch this. Not really. Doesn't really look like a problem. Well, my computer crashed, and I lost probably 20 minutes of video. It's very, very sad. But I still have like 15 minutes. I think I was just looking around, kind of measuring random shit last. I think I found what our problem is. I actually don't know if we showed this, but we saw the PMU would kind of go on, off, sort of, on a thermal camera, or we saw it getting hot, cold, and then it would go down to very low wattage. We didn't really have any liquid damage near the PMU, and it's unlikely that any of the stuff we had over here damaged that chip in any way. It doesn't really die a lot. But what we did look for when I started checking out was to see, you know, we saw that one resistor earlier that maybe didn't look too happy. It was just like a no stuff line, but we still had a mess over here. And upon visual inspection, what I saw You know, really what I did is I kind of went around with my tweezers, looking at resistors that maybe look like a little bit charred. I'll use this capacitor as an example, and I just kind of give them a little love tap. I'm trying to see if they have any play, because that means they're probably not actually connecting, and they have a pad like this underneath them, which is all burnt to hell. I already put some flux on this because I'm getting ready to remove it. This resistor is not actually connecting, and it is a line that tells our PMU to turn on or off. It's a _L, so signal when low, some kind of signal line, yada yada. It's a 100 kilo ohm resistor. I have a box of spares. I'm going to remove it. I'm going to fix the pad underneath the resistor and then put a new one there, and then we will see what the MacBook does. Really, despite how bad this corrosion looked, it's really not too terrible. The only other thing I really noticed was that you know, we're definitely going to want to touch up these joints on this. I believe this is the keyboard backlight connector. Is it? Let me see. I think so. Let's see. Yeah, keyboard backlight stuff. Okay. We'll fix that. The keyboard, we want it to light up. Shine bright. Let's go to our microscope cam. Alright, one side of this resistor is already fallen off. I would like to not rip the pad on the other side, so we have our fume extractor on, so we don't get the cancer. One side's already just kind of totally loose, so you could use hot air, but then there's a plastic connector right next to it, and that's the whole thing. I don't want to melt that and then have to replace that too. I would like to do what is necessary to get the MacBook working, so I can then go and fix more MacBooks. So let's do that. And just scraping that puppy up. We want a nice, happy pad. It's like we have now. Okay, I'm gonna put my hot air at like 300 and just kind of get this area a little bit warmed up. Move my multimeter probes out of the way so I don't melt them. Really like this guy either. Flux is also very good at cleaning. I'm going to do a little bit higher temperature. Go like 320. If I was doing rework not next to a plastic thing, I'd be about 430. So we're about 100 degrees lower. I don't want to melt this connector too much. It's alright if it gets a little bit toasty. Now we see that one just has like no pad either. I'm going to go ahead and just remove this guy too. Yeah, we can see this one was missing a pad, so we removed it. So we'll grab this chip off of a donor. I think we'll just get that resistor on now. We're going to have to run a, let's see if we have to run a jump wire. What is this? Okay, we're going to need to do that. All right. pad there at all. This area with like a Q-tip and some alcohol first. It's kind of charred crap on here. I don't want to be dealing with that. Oh, there's kind of a pad still. Maybe fix that. That would be nice if we don't have to do a jumper. I think since this trace is just totally gone here, I'm going to actually pick a wire from this and wrap it. I'm going to take a wire from here and wrap it around the edge of the board to something over here. It's a little bit more stable because all of these pads are just gone. I actually assume that our inlet, though, is this pad on the chip to the other side of the board, not these. These don't look like they actually go down in anything. It's probably a little bit harder to see on the camera, but you almost see like a little wire core under the pad when it's ripped off like this. We can actually look at those two other caps that were just falling off here. We can tell that this one here goes into the board. Oh, let me move that down. You see kind of a little wire basically at the bottom of it. So that wire ran up through the board and connected to that pad, that line. These two things here are just ground pads. They don't go to anything under the board. Just connecting to like the surface of the board basically. But same thing here, we see a little kind of circle doodad there. That means that's going down into something else. And then obviously if you have a trace that's, like right here, we can just see a trace, or well, that's kind of a whole bad example. But something like this, right? This is a surface trace that runs here to this test point. So we can just trace that visually and see where it goes. Yeah, we're definitely going to want to ultrasonic this board. Okay, let me try to scrape at this a little bit. About as visible as that'll get on the camera. Pretty high zoom. Okay, and that pad is just totally not connected to anything. I do see the via, and it does go through the board. We're going to need to run a wire around the edge of the board. Yeah, okay, so these two lines go to this, goes through the board, goes to the other side. So we don't really care at all about the capacitor that was next to this. But we do care about our resistor. Or this was actually, this one's a no stuff here. But this one we care about on our left side. That seems important. Generally, resistors, you need them. A lot of caps, redundant, you don't need them. We need this 0.1 picofarad cap on this line. Not really. It's not going to cause any problems if it's not there. Yeah, we're okay. It's not a critical component, basically. Okay, let's get our resistor on there. 201 100K resistors are fairly common to need. It's good to just keep some. You can buy big packs of them off of DigiKey or Mouse or something like that. whatever you prefer. Get that guy in his place. Okay, and really what I'll probably, we'll just, we'll make a little coiled up 44 gauge wire here basically to act as our pad. I'll do that on the board. I'm actually going to go ahead and grab a donor first, because what I think I want to do is just get a long piece of wire, actually take my chip, solder to the bottom of the chip, then get this on here, solder this in place, and then we'll start gluing it down and running it to the other side of the board here. Basically, it'll be easier. We can, make it longer than we need to be, and then cut it to length. Probably we'll connect it to, probably just right here, something like that. Should be fine. I should wonder how this. I should see what happens. Yeah, it should be okay. Okay, we'll be right back. Okay, we have one of our many 16-inch donor boards. So we did so many of these in with dead storage. I think I have probably 10 of these in the back of my office. But they're basically fine, except they got dusty. So the board is in a state where all the storage is dead. We generally just opt to replace those. There are some people who do swap out the NANDs on these. But the data's gone in those scenarios anyway. This guy. Care about this connector. I'm going to turn on my heat a little bit. I forgot I was still at like 320. So I was working on the patience and I didn't want to melt the connector. I don't really care if I melt the connector on my donor. There's a bunch. Get this off. That here. Messy desk for wire. Okay. Here we go. I'm getting a big old piece. A big old piece of very small wire. Okay. Foist thing I'm gonna do is these wires are coated. Basically have like an enamel on them. We want to burn off the coating on the part that we were trying to solder to something. Get a little bit of fumbling around with the wire. Put on the camera. Okay. It's the following day now. It's the following day. I have the fume extractor on. Basically, what we want to do is I'm going to basically just solder the wire under this chip because it's not like a large BGA chip. We don't really need to bother with like coiling up a jumper wire and then setting it in place. So what I think will be nice is I'm going to flip this over And we're just going to take the jumper wire that we have. I'm trying to keep in mind how this is oriented. But basically, I'm just going to solder the wire onto that central pad right there, and then we're going to flip the chip over and run it around town. Try to get this in maybe a better position. Like that. Get some flux on there. It is an easier said than done. That takes years of practice. Years of practice. Look at this sort of thing. I'm gonna get my hot air at 320-ish. What was I doing? I'm gonna go like 320. Should be okay. Just kind of want to get the flux a little bit more liquid. Hold this in place. We are going to have to melt the plastic connector a little bit. I think my wire's kind of coming out. I might have to like slip it under a little bit. I'm just going to check the wire for continuity once I get it on the other line. Might be better for us just to run it off to the side and then around. Let's see. And we'll do that just to give less strain. This on these capacitors.
And we'll just put it on this larger one, it's easier. Okay. Stay. Excess off, and then actually thinking like, how am I gonna measure this? Hard because I don't have anything to measure on the top side. I guess I just want to make sure I'm not shorting. We have something here. I guess this is kind of, if anything, it's biased down to here. So let's just make sure we're not shorting this line to ground with that wire. So I think we're okay. Okay. Should be okay. I guess we'll try to run power through it now and see what happens. It's off a little bit more. It seems like it is turning on, then we will ultrasonic this board. And then after I ultrasonic it, I'm going to do glue on my jumper wire and then the SSD power regulator so this person doesn't have their storage kill itself from dust in a year. Okay, let's plug in USB-C and see what happens. Watts. And what we'd see before is we would get like 4 or 5 watts and just kind of shut off. Now we're getting, yeah, this is on now. The MacBook seems to be on. I'm going to stop running power through it because it is still pretty dusty. That was why our PMU was lighting up and turning off, is because there was an on-off signal that was sad, basically. So now we have a fun little wire wrapping around the board. We'll ultrasonic this and then put it back together after doing some conformal coating on a few key areas, and then we will test it. It'll be okay. All right, our board is shiny now and clean. We're going to use the fancy blue conformal coating glue to hold down our jumper wire and cover our TPS SSD controllers too. Okay, let's tack this down. Gonna get a pretty good glob there. We're globbing. I really don't want this to get knocked off by anything later. That is why I am using so much conformal coating. I'm actually going to dab some of this off with a Q-tip because that is kind of way too much. It just doesn't need to be like this thick of a layer. I'd rather not have it stick up from the board so much. What I will do is kind of like tuck in the edge of it so it sits flush on the end of the board. Like I don't want this sticking out like that. I want it like right up against the board. So I will find my UV light. So battery. And I will let a UV light sit on this for a few minutes, which I will not record because it's boring. The MacBook should live. We've cleaned it very thoroughly. We have added the thermal paste onto the CPU. We have coated this SSD controller. We have coated our jumper wire for our PMU on-off line. And we have also coated the other SSD controller. So now we're going to put it back together and test it. I think there's maybe a few parts in the chassis for this that are going to be bad, like the headphone jack. When we're doing board repairs, any parts that are bad, we just swap them out for cost. Basically, we're already kind of mostly taking it apart anyway. So we shall see. If so, those are all pretty cheap parts, or a few dollars, $5-10. No biggie. We'll get this back together though and see what else is misbehaving. I think there's maybe some parts in the chassis that are going to be bad. Okay, you know what? Actually, the headphone jack on this looks okay. I think our main thing is going to be that keyboard backlight connector. I actually wanted to double check. Kind of forgotten about this connector. Yeah, I'm gonna touch up the solder on these joints. I forgot about that. But inside of the chassis here, this is where our liquid damage was. I have already cleaned this off fairly thoroughly. There was some kind of superficial corrosion on this. It's been cleaned off. That's probably fine. Fan connector's okay. Keyboard backlight connector is just absolutely burned to shit. So I'm actually going to put flux on this and try to just get some solder to like recoat these pins. We'll see if that works. Otherwise, we'll ask the guy if he cares enough about his keyboard backlight to replace the top case, which we can do if you would like. It's just that is one of the few parts in here that is, it's pretty expensive. I think it's $150, $200 for a good top case with like a new battery and that sort of stuff. Which isn't that at all. This machine's fairly valuable still, and still makes sense to fix. Let's do, well, I have this right here, so let's just do this really quick. I'm gonna move this somewhere where I'm not gonna knock it over. And those are just totally gone, unfortunately. Okay, well, some of these are our actual lines for the keyboard backlight because they're burned and destroyed, and probably other ones are just ground or no connection or something like that. These would be, what am I looking at? Okay. So yeah, this is our V out for backlight. Basically, there's two right pins. The two middle ones are actually no connection, so these two that are just totally gone were our keyboard backlight. We don't really need that for a working machine though, so we'll ask the customer if he wants to replace this. He's typing in the dark. Let's touch up the connector on the board anyways, in case he wants to do it. It'd be easier just to fix it when the board's out of the chassis like this. I think I will probably just check with this customer to see if he wants to swap out the keyboard, and if so, we'll just swap out this connector entirely. I did clean up the connections a little bit, but they're pretty toasted. But we don't even have a working keyboard backlight anyway, so there's really no point in swapping out this connector if we essentially if the customer doesn't care about the keyboard backlight. So we'll check with them first and then see if we're doing this or not. Our MacBook seems to be largely happy. We just replaced one of the USB-C ports. Screen looks good. All the keys are good. The touch bar works. We just have no keyboard backlight. Couldn't get a hold of the customer, but
Honestly, I'd probably skip it. The keyboard top case on this is pretty expensive. I'll ask him if he wants to do it. We can swap it out, but you know, I probably wouldn't recommend it. Seems okay. It's like another, you know, $150 for your keys to light up. I don't know how much this person works in the dark, but it's probably unnecessary. Primary faults on this, basically, we had a little PMU on-off line that was misbehaving because there was a pad on a resistor and there was a pad under a little amplifier thing that were not actually there because they were corroded and burnt off. And then we had a few kind of fall off the bone capacitors that were probably shorting. In any case, they shouldn't have been left on the board, so we removed them. And that is pretty much that. So this is a rare, you know, A2141 where it's not a dead SSD controller, which is always a fun treat to not have one of these with dead storage on my table. Hopefully we never see this computer again, and we will see you next time I remember to record a MacBook board repair or whatever else might be here. Have a blessed day.